Hello.
Hi. Hi, good evening, everyone. And I would like to thank MRSI for allowing us to present the paper. I'm pretty sure we are important because we are replacing Piyush Goyal. Anyways, um, so basically, what we were talking about is AI and AIs, another acronym for AI, which represents artificial eyes. It's an retail monitoring solution where basically we are using computer vision to kind of solve multiple problems that especially are available for unorganized retail. To introduce the team, sorry. I'm Abdur. We have Darshita and Sumit along with me. Unfortunately, Abhimanyu is not able to join. So moving on, um, I think since the beginning of these session, we have been talking about AI, machine learning, NLP, computer vision, and how it is changing the landscape of consumer research, analytics, and essentially how we do business. And that's broadly what our solution also does. So for a CPG major, we basically kind of use computer vision to ease out the entire process of a retail journey. Now, whether it is data collection, whether it is insight generation, whether it is data augmentation, and so on and so forth. And if you talk about generally, when you go to any unorganized retail store, and you think of how an sales individual will collect the data, right? There are a lot of processes to collect the data, right? And we are kind of solving multiple problems for them. We are solving problems around compliance, which is what products actually should go to the shelf. We are solving forecasting problems, which is essentially means how much product should be stored in a particular store. We are getting competitive intelligence, which is basically what is the pricing of the products of competition, how much products the competition is selling, and basically assortment optimization, which is broadly letting the stores know that what assortment should they carry, right? And all using a single computer vision solution. If you
Recording in progress.
all right. And just to give a little high level insight into the impact, this impact is universal, right? We are saving a lot of man hours in terms of the effort put in by individuals to collect data. We are improving customer experience by increasing the net promoter score, improving the bottom line by increasing the revenue. And it's a solution which basically is processing GBs of data across thousands of, or in fact, hundreds of thousands of stores, and obviously around competitive intelligence. So just to give when we talk about why AI for smart insight solution, right? And if we just take an example, you think about just the journey of how generally the data collection happens. So when a sales representative basically kind of goes to a store, they basically collect what are the products that are there on the store. They see what does the competition is doing, what is the pricing of the competition, and just imagine the kind of time and effort that basically goes in collecting the data. The data is basically recorded, maybe it's manually recorded, entered into a system, and basically then this data kind of gets processed. And if you think of the problems associated with this kind of an data collection processes, it's manual. There is a lot of latency in terms of the data. The data is error prone. Costly, right? You can't even think of collecting data for thousands of stores. And it's time consuming, right? So basically the stage from data collection to data consumption itself is a long process. And by the time the insights are generated, maybe it's already too late. And that's what we are basically trying to solve using computer vision. And that is why if you see the opportunity to basically use AI is huge, right? You can make the solution scalable, you can make the solution cost effective, make it real time, and so on and so forth. So just to go into the more details of the solution, I'll just hand it over to Sumit to kind of walk you through in terms of how does the solution happen and what are the things associated with it.
Thanks, Abdul, for talking about the problems that we are solving and also the opportunity which we are leveraging. So let's talk about how does it actually works, the solution that we created. So basically, what we have is, Abdul told about the problem. So it looks like it's a very, very, very complex problem and it should have obviously, a complex solution, but that's not the case. What we have done is, we have used the technology as an enabler so that the end user, which are, for example, sales representatives and the people who take business decisions, they can use it very easily and efficiently. So the problem flow is, the solution flow is, the videos and photos gets captured from the locations like the sales outlets, and those videos and photos gets passed through the AA application. That AA application does some sanity check. Let's say the image of that particular rack or that particular region of interest is not blurred, or let's say it's not parallaxed. It's further, after this, the vet and the sanity check, that particular image gets uploaded on the cloud by the solution itself. Once it is uploaded, our state-of-the-art image processing and computer vision algorithms extract spatial information out of it. So let's say what products are there, where are those products, what type of rack it is, what is the price of a particular product. So that type of information is extracted out, and what we do is, after that, generate KPIs on that. And once those KPIs are generated, it definitely gets pushed to the dashboards like Power BI or the websites of our particular clients, so that they can take better decisions in real time. If we move forward, let's see the output. How does this look like? I don't know which part is slow. Okay. So do we have CPG, like the companies from CPG? Kellogg's, Nestle? Okay, so hear me out. So for Nestle, let's say Kit Kat. For Unilever, let's say it's your maybe Dove. So let's say all of these things are placed on the shelf, and your sales representatives go to your retail store, and all he needs to do is, he needs to click a photo. Just click a photo through his mobile app. That particular photo gets processed through the computer vision algorithms. And the first part is, what we do, we take out spatial information, like what type of SKUs are there, maybe Kit Kat, Green Lays, or so those are the SKUs. And after that, what we do is we check what products are missing in that rack, and then we check some other stuff. After that, after using that special information, we develop KPIs. For example, compliance. How much compliance that particular rack is following. How much out of stock situations are there. And let's say key recommendations. We can give that also. Forecast. And interestingly, we can also run this solution on our competition. So let's say next time we want to, like KitKat wants to check all of these KPIs for, let's say, Cadbury. So they can click the images of Cadbury rack and they can calculate these KPIs. Let me just give you, I think Darshita will be talking about, so I just talked about the output. So Darshita will be talking about the actual, how a particular user will be going through this process. Thank you.
Thanks, Amit. So just now we saw a single entity, which was an image. When fed it to the solution, it calculates, multiple KPIs, and it is able to generate the n number of insights. Is it fine? Okay. So, like we calculate the multiple KPIs and we were able to generate n number of insights. But this solution is not limited to just a single entity, but it is a in-store retail analytics which is able to capture image on the go. That is, the sales representative can go into the store and can walk in just and capture the video, and from the video we will be able to detect the racks, and on the go we will be able to calculate all those KPIs, and this solution is hence real time. So just to give you the glimpse, what is at the back end, like what how the solution is, structured. We have multiple modules which are working, in conjugation with each other, and these multiple module comprises of the deep learning computer vision algorithms. Now we have used the transfer learning based approach so that we will able to do the object detection, image qualification, image segmentation, depth estimation, object localization, and image to text. Now this is where, technology has enabled us to, generate multiple insights. So, moving towards the architecture. Now you can see the three main zones, which is the machine learning zone, landing zone, and the publishing zone. Now these three zones, they work independently. We have the publishing zone, which is the end, like this output. So it is independent of the other zones. We have the machine learning zone, which is scalable. Scalable as in, like whenever the number of users are increasing, the worker nodes are increasing. And whenever we don't have that much traffic, the worker nodes will automatically decrease. So hence this particular portion is scalable. Then we have the landing zone, which is basically the data mart. Now this whole solution, we have basically shipped to this solution by containerizing it with the help of the Dockers to the client, so that the client can just, use it in a plug-and-play manner. So to conclude, I'll just hand over to Abdul. Thank you.
And just to add, if you can just hold on. I think the point about why we are trying to show, I know it's a little technical, but I think the point that we are trying to make here is that everything that has been designed is modular in nature, right? You have something like a landing zone which is collecting the data. You have something like a machine learning zone which is actually generating the insights. And then there is a consumption zone, which is the publishing zone, right? And all of this basically can work independent of each other, right? If just people want to just use one of the module, which is just the intelligence zone, they can use that. If people want to just use the publishing zone, which is mostly the consumption area, that is something that people can use, right? The idea is that the more the modular you make, the more scalable it is, the more widespread it is, and internally those solutions can be kind of bespoke and used across other multiple clients. So I think that's broadly how the magic kind of works. Coming back and kind of looking at this solution, it's not that it is only applicable to basically retail, right? You have capability of using this solution across, right? And that's what you would see, right? So if you talk about insights monitoring, the monitoring can happen in retail, monitoring can happen in manufacturing, monitoring can happen across a lot of other industries, right? And that's what basically the scope of this kind of solution is. You can basically accurately get insights of the shelves. You can work with a lot of internal data, your sales data, your transaction data, to generate more insight. You can identify competitors, what your competitors are doing, the pricing that the competitor has, the kind of assortment your competitor has, and so on and so forth. You can do easy evaluation, right? So basically, all the insights or all the KPIs that were generated is something that is available on the handheld, right? Which means that you don't need any specialized hardware. You can just work on commodity hardware. You can just work on commodity system to basically get those insights. And eventually, I think one of the most important pieces basically scale, right? Scale with minimal cost, right? And that is something that we were discussing, right? That it's not that you can always do a quick and dirty thing. It is quick, it is scalable, and it can be expanded across industries. So coming back to basically where we started off is, this is one validation of the solution that we have developed, right? Across the impact across areas, impact on the P&L, impact on customers, impact on cost, and so on and so forth, right? That's where kind of I'll stop. Any questions on this?
Any questions?
So we do have one question. I'll just read it out. How difficult is it to train these models for India context with no standardization at the stores?
See, honestly speaking, it's not that difficult, right? See, if you talk about, though it could be India, it could be any other country, if you actually talk about products, they are quite standardized, right? So for example, a pack of chips would be very similar in India compared to any other country, right? Similarly, a bottle, right? So these are kind of generic shapes that are available, right? So, and even in terms of if you see a biscuit packet or if you see a chocolate packet, right? These shapes are in a way universal or standard. Yeah, maybe they may be big, they may be small, they may be circular, they may be oval, but in general, right? These are shapes which are generally identified by humans, right? They are not shapes which are not defined. So that way, if you want to kind of scale it up across products, if you want to scale it up across categories, it's fairly easy. And kind of once you have kind of put the things in place, then you can definitely scale it up across products, across industries, across different categories of products, and so on and so forth.
Like, just to add to what Abdur said, the solution is already currently running for I would say demography or geography which is similar to India, on which the solution is currently running. So that's like not a problem. And also we have image sanity checks and algorithms which runs before the modeling step. So whatever the garbage is in the data, we clean it out.
Right, and just one final point. We categorically said that this solution is for unorganized retail, right? See, when you talk about organized retails, a lot of things are standardized, right? So it's very easy to do this kind of solution. Whenever, especially when you talk about mom and pop stores, unorganized retail, that's when the technicalities come into picture. And what we are talking about, the racks that you see over here, is primarily for unorganized retail. So if you can solve it for unorganized retail and the products which are there in unorganized retail, I'm pretty sure that it's fairly simple for organized retail, because that's definitely a lot more standardized and a lot more, kind of more structured in nature.
So while you just mentioned about organized and unorganized retail, we do have one more question on those lines. How are you calculating NPS at an organized retail level?
At an what level?
Organized retail level.
Yeah, so see, standard way is we are doing this for a lot of mom and pop stores and outlets, right? And obviously we know consumers or the trade areas for each of this kind of outlets. So we have kind of implemented this solution for some of the outlets. We haven't implemented solution for like the standard A/B testing, test and control, right? And what you see is that how is the NPS being impacted in the trade area for the outlets where the solution is implemented, right? And what we see is a definite incremental value in NPS for outlets where it's or the trade areas or the outlets where it is implemented.
Okay, I think that's it. We don't really have any more questions. Thank you so much.
Thanks a lot, everyone.
for your
Thanks a lot.
contribution and the presentation.